In this video, let us see the second example. ABCD is a rhombus and PQRS are the midpoints of the side AB, BC, CD and DA respectively. You have to show that PQRS is a rectangle. Okay, so we have to show PQRS is a rectangle. So what we are doing here is the figure is not given to you, so only this much you have to draw whatever has been given to you. Okay, and what is given is ABCD is a rhombus. So since ABCD is a rhombus, you know AB will be, all sides are equal in a rhombus, so AB will be equal to BC, equal to CD, equal to AD. Now we have to show that PQRS is a rectangle. So to show that this is a rectangle, you have to show that PQRS is a parallelogram. One of the interior angles is 90 degrees and also the opposite sides are equal. So if you show this, then you know this is a is a rectangle. Now in order to show this, what we are going to do is we want to use midpoint theorem. Since midpoint is given to you, you know you have to use midpoint theorem. To use midpoint theorem, if these lines are not given to you, you don't have any triangles. So for that reason, we join AC and BD. Okay, and let these two diagonals intersect at the point O. So now we have got triangles which we can use to show that PQRS is a rectangle. Now let us show that PQ and say SR are parallel. So let us show that PQ and SR are parallel. Okay. So for that, if you want to show PQ and SR are parallel, just like the previous example, first we will show PQ is parallel to AC and SR is parallel to AC. So PQ will be parallel to SR. Okay. So in triangle ABC, we have P is the midpoint of AB and Q is the midpoint of BC. Correct? So by midpoint theorem, you know PQ will be parallel to AC and PQ is half of AC. So let us number this equation as 1. Now let us take the other triangle, that is triangle ADC. So in triangle ADC, S and R are the midpoints of the sides AD and CD respectively. So by midpoint theorem, we know SR is parallel to AC and SR is half of AC. So let us number this equation as 2. So from 1 and 2, we can say PQ is parallel to SR and also PQ is equal to SR. So PQ is parallel to SR and PQ is equal to SR. Correct? So we can use this theorem which says if one pair of opposite sides are equal and parallel in a quadrilateral, then it is a parallelogram. So PQSR or PQRS is a parallelogram. So next we have to show that one of the angles is 90 degrees. So what we are going to do is we are going to take the triangle OMNQ. So in triangle OMNQ or ONMQ. So now in quadrilateral OMNQ or OMQN, what we know is that MQ is parallel to ON. What is the reason? We know PQ is parallel to AC, correct? PQ is parallel to AC and MQ and ON, or MQ is part of PQ and ON is part of AC, correct? So if ON is a part of AC and MQ is part of PQ. Okay, so we can say PMQ will also be parallel to ON, correct? Similarly, we know QR is parallel to BD, correct? We know that. Similarly, we can show that QR is parallel to BD by taking these two triangles, or this triangle we can say QR is parallel to BD. So since QR is parallel to BD, we can say QN is parallel to OM, correct? QN will be parallel to OM because QM is part of RQ and OM is part of BD. Now, since the opposite sides are parallel, we can say OMQN is a parallelogram. So, this is a parallelogram. Now, angle MQN, okay, this angle will be equal to angle NOM. Okay, this angle will be equal to this angle. What is the reason? Because it is a parallelogram, correct? Now, angle NOM, okay, this is 90 degrees. What is the reason this is 90 degrees? If you know that ABCD is a rhombus, correct? And AC and DB are diagonals of a rhombus, and the diagonals of a rhombus are perpendicular to each other. Okay, so diagonals of a rhombus are perpendicular, so this is 90 degrees. Now, since this angle is equal to this angle, even this angle will be 90 degrees, correct? So, angle NOM is 90 degrees. So, this angle is also 90 degrees. That is, MQN is also 90 degrees. Instead of writing MQN, we can also write it as PQR. So, PQR is also 90 degrees. So, you know, PQRS is a rectangle. This is a parallelogram and one of the angles is 90 degrees. So, we have PQRS is a parallelogram in which one of the interior angles is 90 degrees. Now, this is the second condition. Third condition is the opposite sides are equal. Since it is a parallelogram, automatically the opposite sides are equal, correct? So, all three conditions are satisfied. That is, PQRS is a parallelogram. One of the interior angles is 90 degrees and opposite sides are equal. So, since all the three conditions are satisfied, we can say PQRS is a rectangle.